We're going to be looking at multiplying radicals. So our last lesson, on lesson number 2, we looked at adding and subtracting radicals. And today we're going to look at the differences in adding, subtracting, and multiplication. So first thing, if we look at the multiplication of algebraic expressions, recall that we use the distributive law, and we also use the distributive law or FOIL in order to solve those types of products. And if we were to apply the distributive law, then remember I got to take this coefficient and distribute it into my my polynomial inside. So 4 times x would be 4x, and 4 times positive 8 would be positive 32. Likewise, if I were to apply that same reasoning here, I would say negative 2x times 3x would give me negative 6x squared, and negative 2x times negative 5 would give me positive 10x. And then using the distributive law, or foiling first, outside, inside, last, to determine products, we would do the same thing, but we'd have to distribute more than one term. So x into 2x would be 2x squared. X times 1 would be positive x. 6 times 2x would be plus 12x. And then 6 plus 1, or multiplied by 1, would be 6. And then I would combine like terms, giving me 2x squared plus 13x plus 6. And this example here is the exact same thing, but I have one extra term that I need to deal with. So in this investigation, what we want to do is use a calculator to determine whether the following statements are true or false. So if I have the square root of 3 times the square root of 5, I want to know if this is going to be equal to the square root of 15. And the answer is yes, it is. So this is true. Square root of 2 times square root of 6. You'll also find that this is true. Six root 2 times 4 root 3. So 6 square root 2 times 4 square root of 3. Is this equal to 24 square root 6? And the answer is yes, that is also true. So I'll let you complete these ones below, and I'll let you determine whether or not these are true statements. But based on these 3 results, we want to write a rule that describes the process of multiplying radicals. So when multiplying radicals, we want to multiply our coefficients by the coefficients and radicals by radicals. So in general, if I have x root y, I would want to multiply this by x root y, which would give me x squared, y squared, or x times x and y times y. So multiply numerical coefficients by numerical coefficient, multiply radicand by radicand, and simplify into mixed radical form if possible. So let's look at these examples here. I'll do the first 3, and yeah, all the rules are the same, and so these 3 questions end up being repetitive, but 5 times 2, we would end up with square root of 10, and I can't simplify that at all, so I will leave this as square root of 10. 6 times 6 is root 36, or simplified is 6. 2 root 5, so 2 times 4 is 8, and 5 times 6 is root 30. Now we want to think about whether or not we can make root 30 any smaller. I have 3 times 10, I have 15 times 2, and if I think about all the different combinations of 30 and factors of 30, there's no perfect squares in there, so that's as simplified as we can get. And let's continue on example number 3. And actually, I want to do example 1D here instead. Sorry, I just looked at this one, and this might be one that's worth doing, but same thing, coefficient by coefficient, I get negative 15. Radical by radical, the radicand by the radicand, I get square root of 9. So this would simplify to negative 15 times 3, or negative 45. Okay, now let's look at example number 2 here. I have the following products. This would be the square root of x squared. And if I have the square root of x squared, that's just equal to x. The square root of 8 square root a and 9 square root a would be 8 times 9 is 72, and a squared, or 72a. And then here, 2 and 5 is 10, and then square root of x times y is xy. And last, let's write and simplify an expression for the area of each shape. I'm just going to do this example here. Now I'm looking for the area, and I know that area is equal to my length times my width, or area is equal to length times width. Now I'm going to designate this my length, and this one I'll call width. So area is going to be equal to 7 minus the square root of 6 times my width, which is 4 plus the square root 6. Now this is where we need to use our distributive property, or our FOIL method, in order to solve. In order to solve this by FOILing, remember that just like when we looked at polynomials last year, we take our first term, so my 7 times 4, and I'm going to end up with 28. Then my outside term plus 7 times root 6 is 7 root 6, minus, because of this, my inside term, 4 root 6 minus root 6 times root 6, which is the square root of 36. Now I can simplify by combining like terms. 28 plus 7 minus 4 is 3 root 6 minus square root of 36, or 6. So my area is going to be 28 minus 6 is 22 plus 3 root 6. And this is an expression that can't be simplified anymore. Okay, so there's 3 things you got to be aware of: is multiplying the numerical coefficients by the numerical coefficients, multiplying the radicand by the radicand, simplifying into mixed radical form if possible, and then if you have multiple terms you're multiplying, like in this example here, and we'll do a couple of these in class, but in these examples as well, you'll find that you need to use your distributive property in order to solve.